Alright, another method that we can use for integration in situations that U substitution won't work would be this idea of long division. Okay, so when using long division to integrate something like, say, 2x over x plus 5, what we're going to want to do is we're going to want to put x plus 5 on the outside, 2x on the inside. So you're always going to put your numerator inside the division symbol, and you're just going to work that out from there. And what it'll do is it'll yield something for you. Right, so if I did some division here, let's do something relatively elementary for a moment. Let's take 9 divided by 80. Well, 9 goes into 80. I wish it was 81, that'd be great, but it's not. It's 8, and then we multiply and we get 72, and we subtract and we get 8. So it looks like we get 8 with a remainder of 8/9, right? 8 and 8/9. So we're going to do the same thing, except now with polynomials. And you should have done this in pre-calc with some polynomial long division. And typically long division problems will only be polynomial related. So it looks like this would go in 2 times. I'm going to put plus 0 here. It'll go in 2 times, making that 2x plus 10. And then we'll subtract, the 2x's will disappear and I'll get negative 10. So the answer to this, when I divide x plus 5 into 2x, I get 2 minus 10 over x plus 5, which may not look like it, but it's a lot easier to integrate. So I'm going to integrate this using 2 integrals. I'm going to pull out that 10. And what you should see is relatively easy. We'd have 2x minus 10 times the natural log of x plus 5 plus c. Okay, if that natural log piece just isn't jumping out at you, it will after we do a bunch of these. Alright, let's look at the next one. Okay, again, I'm going to take x plus 2 here. I'm going to put x squared minus x minus 5 here. X goes into x squared x times. I multiply through, and then I subtract. Okay, be careful here. This is negative 3x. I drop down this negative 5. I do it again. I get a negative 3. I multiply through. And it looks like when I subtract, I get a remainder of 1. So I get x minus 3 plus 1 over x plus 2. Okay, that remainder will go over whatever this term is here. So I'm going to take the integral of x dx minus the integral of 3 dx plus the integral of 1 over x plus 2 dx. This should be screaming natural log in the end there. So I'd have x squared over 2 minus 3x plus the natural log of x plus 2. Now, check it out. This is a definite integral. So I have to evaluate this from 1 to 2. Let's do that on the side, and we'll come back and check our work. Okay, so I've gotten this far. I could still do a little bit more work. Okay, negative 4 is really negative 8/8, or excuse me, negative 8 halves. So negative 8 halves minus negative 5 halves would be a positive 3 halves. Oops, I'm sorry, a negative 3 halves. Okay, and natural log of 4 minus natural log of 3 is going to be the natural log of 4/3. That would be the evaluated integral. Okay, let's do one more here, and let's see how it goes. So x squared plus x plus 2 divided into x cubed. What should I do here? Plus x squared plus 0x minus 1. I put that 0x in there as a placeholder. So x squared goes into x cubed x times. Multiply it through. Okay, subtract. Those disappear, and x cubes and x squareds disappear. I get a negative 2x minus 1. Okay. Because the x squareds disappeared, I won't have a constant term up here. So what I have here is actually my remainder. So I'll have x minus, actually, yeah, we can do it that way. No, let's not. Let's go x plus negative 2x minus 1 over x squared plus x plus 2. Alright, so this may not look like it, but it's actually not that bad to integrate. I'm going to integrate x dx, and then I'm going to pull a negative out, minus the integral. That will make this 2x plus 1 over x squared plus x plus 2 dx. So this integral is easy. This one actually isn't that bad. I'm going to set u equal to x squared plus x plus 2. That'll make du dx 2x plus 1. Ooh, look at that. So du will equal 2x plus 1 dx. Direct substitution. Right, this would make this 1 over, right, 2x plus 1 dx. I would just put in a du. Okay, and I'd have 1 over u du. Right, the integral of 1 over u du is the natural log of u. So I'd have minus the natural log of 1 over u, which would be, no, excuse me, natural log of u, which is x squared plus x plus 2 plus c. There you have it. An alternate form that you might see would be the following. If I made this a positive, that would take the item in the natural log and put it in the denominator. That's another way you could see that answer. Alright, that is long division. I hope it went pretty well for you. Let's see, actually, the second page. Oh my, there's the second page. Alright, let's do one more. Let's do, how about number 4? Alright, let's do our long division on the side. Make sure you get your placeholders. Okay, let's do some division. That would mean this is x squared. So x squared times x is x cubed. Cancels that first term. X squared times negative 1 is negative x squared. Okay, so when we subtract, x cubes cancel. I get a positive x squared plus x. Looks like this will go in x times. When I multiply through, I get x squared minus x. But when I subtract, that gives me a 2x plus 0. Okay, so how many times does x go into 2x? It goes in twice. I get 2x minus 2. So it looks like I'm going to have a remainder of 2. So this integral would be the integral of x squared plus x plus 2 plus 2 over x minus 1 dx. Alright, this 2 is the final 2 right here. Alright, so I can integrate this pretty easily. This will be x cubed over 3 plus x squared over 2 plus 2x plus 2 times the natural log of x minus 1 plus c. Let's see if we get it right. That's number 4. Number 4 is x cubed over 3 plus x squared over 2 plus 2x plus 2 times the natural log of x minus 1 plus c. Alright, that's it. I think that's good for today. That is long division method of integration. Have a great day.